Hi everyone, and welcome back to educator.com. In this mini lesson we're going to do page 1 of the A+ Physics worksheet on circuit analysis. So with that, you'll find the link down below. We'll dive right in. Number 1, a 30 ohm resistor, a 3 ohm resistor, an unknown resistor R, and two ammeters A1 and A2 are connected as shown with a 12 volt source. Ammeter A2 reads a current of 5 amperes. Determine the equivalent resistance of the circuit. Well, the way I'm going to solve something like this is I'm going to go through and I'm going to make a VERP table. And what I'm going to do is I'm going to name my resistors. Let's call that R1 and that R2. So the elements of my circuit, I have R1, R2. I'll have a row here for total. I'll have a voltage, a current, a resistance, and a power. I don't think I'm going to need the power in this one. We'll write it in there just in case. And we'll fill in what we already know about the circuit. We know R1 is 3 ohms. We know our total potential difference is 12 volts. We know the current through the entire circuit is 5 amps. All right. We can figure out, once we know two things in any row, we can figure out the others. So resistance is going to be V over I. 12 over 5 is just going to be 2.4. Since this is a parallel circuit, we're going to have the same potential drop across both resistors, so we can fill that in, 12 and 12. And current equals V over R. I equals V over R. This will be 4 amps. If we have 4 amps going through R1, well, if we had 5 amps here, we have 4 amps going through R1, we must have 1 amp going through R2. Now I can figure out that resistance of our unknown resistor, R equals V over I, or 12 ohms. So determine the equivalent resistance of the circuit. The equivalent resistance of the circuit we already found out was 2.4 ohms. Now, as we do this, we're going to answer the next couple questions using that same table. So number 2, calculate the current measured by ammeter A1. Well, the current through A1 we said was going to be 4 amps, right from our VERP table already, so 4 amps. And number 3, calculate the resistance of the unknown resistor, also right from our table, that was 12 ohms. have 0.67 amps. Those must come together to give us 2 amps as our total current. So we can figure out now our total resistance, R equals V over I, which will be 12 ohms, which makes sense. Our equivalent resistance should be less than any single resistor. And while we're here, we could calculate the powers too. Power equals V times I. 24 times 4/3 is going to give us 32 watts. 24 times 2/3 is going to give us 16 watts. And 24 times 2 will give us 48 watts, or we could have just added up the powers through each resistor. So now that we've got this VERP table, we can answer any of the other questions that are going to come up. So for example, as we go through the next one, calculate the equivalent resistance of the circuit. We just did that. The equivalent resistance was 12 ohms. And calculate the total power dissipated in the circuit. Our total power dissipated was 48 watts. All right, as we do these then, there's our 48 watts. So we've got answered all 7 questions on the worksheet. If you struggled with any of these, now would be a great time to go back and review the video lesson on circuit analysis and VERP tables, or if they went great, terrific. Time to move on. Keep moving forward. Thanks so much for your time, everyone, and make it a great day.